Hello everybody, my name is Sally-Ann Spence and welcome to the Hills Quarry Products dig site in Cerney Wick. Now we have material from both the Ice Age and the Jurassic coming from this incredible excavation, and we have students from over 20 universities and various people coming in from all over the world to participate in this dig. We also have loads of different professionals and experts coming in, and one of those is actually here with me now. This is Max Dereme. Hello Max.
Hi.
Now you've come from the Netherlands.
That's right.
And you're a palaeo-ecologist.
Correct.
And you've got on your thing, can we just show everybody here?
Yeah, little
we have
nickname on.
Mollusc Max. So Max, I'm assuming molluscs are where it is for you.
That is absolutely right. Since actually quite a young age, I've loved seashells, molluscs, fossil or not, and quite happy to be doing some very, very hardcore mollusk science right here at Cerney Wick.
And what's it been like for you? Because you've been here on this dig before, haven't you?
I have. So my first day on the dig was actually last year. And on that first day, so I knew that there would be Jurassic rocks here available from a pretty unknown formation. And on that first day, I almost immediately found a tiny little gastropod, which I don't have on me, but I was very likely to be an entirely new species. So I knew straight away we are at a very, very special site, which is why I decided to come back here this year and lead the project to really study all of these mollusks in depth.
And it's absolutely fantastic. Now, please do look through our videos because you will find that we actually go and chat to Max and his team in his work area. So go back and have a look at those videos. Now, for the students coming on this dig, they also have to take part in camp life because it's a 3-week dig. We're 1.5 weeks in, so we're halfway through, and they live in a tented village behind us. And they have to do lots of other jobs, not just the fun excavation work. They have to learn all these different things. In fact, you've been teaching and leading some sessions as well, haven't you?
That's correct.
And one of the things they have to do is things like the water, the cooking and various other things. And we have Guy, who's going to be our cameraman. So thanks Guy for helping us. And we're in a minute going to be asking Guy to bring the camera in so we can have a closer look. Can you show us some of the things then? Let's see what we've got. These are beautiful.
Right, yeah. So we've got here an array of different fossils that have been collected over the last few days from the pit right behind us, or in front of us in our case. Before I go into exactly what these are, I think it's important that we start off with some context. So we're looking here at fossils from the Kellaways Formation. And the Kellaways Formation dates back to the Middle Jurassic.
Yeah.
And so these fossils are roughly 164 million years old. At the time, this area of England was under a somewhat shallow sea. We were very much in the open ocean, but not quite deep. And it was absolutely full of marine life. We've got there the big marine reptiles, iconic ammonites, and of course a wide array of different types of other mollusks.
I was going to say, that's one thing we have noticed, that there's blocks of they're just solid shells.
That's
right.
right.
Huge amount of life out there.
There's no good examples of that in the specimens I've selected here, but indeed some of these blocks that you get, they're what we call bioclastic. And so bioclast is when a rock is filled with essentially biological remains, in this case fossils, and they are absolutely chock full, some of them. In a 1 centimeter square area, you'll see maybe 10, 20 different bits of shell, whether they're bits of graphia or gastropods or whatever else. Some of them are absolutely ram-packed. Some of them are less rich but preserve bigger and nicer, more complete specimens, which is a bit more what I've selected here.
I was going to say, so tell us why you've selected these specimens then to talk about.
Right, well I just wanted to show a selection of fossils that were a bit nicer for the camera, that maybe needed a bit less prep. So a lot of fossils need to be prepped, which is removing the matrix. This is an example here. You can see that there's still quite a bit of matrix on this shell.
Oh yes. Yes.
So in the lab with like a mechanical kind of pen that drills, like a mini drill bit if you want to put it that way, we can remove all of that sediment and really make the fossils pop out, more like this. This one hasn't been prepped, this one we just got a very lucky pop out of the rock. But in the future, many of these fossils will be prepped, including the centers of these ammonites as well, and stuff like that.
So we've got different species here. Obviously we have with the the fact we've got ammonites and bivalves and things like that, but are they all sort of the ammonites the same species? They look slightly different?
No, so they are indeed different species. I'll start off by showing this guy right here. So this is an ammonite called Sigiloceros caloviense. Now, this is an important ammonite because it is what we call an index fossil. Index fossils tell us exactly what layer we are in. And so when we are finding this species of ammonite in the rock, then we know that we are in what we call the caloviense zone.
Okay. Okay, so that helps us date it, as you say.
It helps us date it and understand almost predict what the rest of the fauna would look like. Though we have found that those predictions need to obviously have been made in the first place, and they have not been made in the case of the Kellaways, which is why so many of the things that we're finding here are completely new to science.
That's very, very exciting.
Yep.
That's very exciting. Right, and do you think on this dig alone, we're 1.5 weeks in, do you think we found some new subspecies potentially?
We have found quite a few new species. Now, unfortunately, I didn't bring too many of them here because
we need to check them and describe them and everything.
Exactly,
don't we?
And for a due process, I'm not quite allowed to, show them off to the public just yet. But we have indeed quite a few new species. So that happens in a few different ways. Some of them are species that are already known, but not yet from the Kellaways Formation. So they're new species for the Kellaways Formation specifically. Some are new species for England. They have not been found in the English fossil record yet, but we have found some examples, for example, from Polish or French records that look very similar. And some of them are just entirely new species to science. So these are things that have never been seen by anyone before, never been described, and that is obviously the most exciting of all.
Oh, that's amazing, Max, and no wonder you're here. I mean, I'd definitely get on a plane and come if that was the case. That's fantastic. And that's going to be amazing because you're going to be involved in the whole process.
Exactly, yeah. So it's what I actually, at the end of the dig last year, I spoke with Sally and Nev, the organizers of the dig, about doing this kind of project in a more concrete fashion, becoming a team leader and having a group of volunteers with me to take on some of the workload, and also people I can then train in these skills, into identification, collection, cataloging, and of course the collection of these molluscs, which is quite different to the collection of the Ice Age bones in terms of the techniques involved. And so it's been brilliant. They were very keen to get me on, and I did quite a bit of prep work, trying to find trying to skim through the very little literature that was available on the subject area. And the project has been going surprisingly well so far.
This is going to be very hard for you to leave then, because you're leaving us now, aren't you?
That's right. I'm leaving tomorrow, which is roughly halfway through the dig. Much too early to my taste. I wish I was staying all 3 weeks, but alas.
Oh, yes. Well, we're going to be collecting material that you will see anyway, so
yes.
it will be quite good. Right, so what else would you like to show us?
Right, well, I've chosen this selection of fossils here because it shows kind of some of the variety that we get. Now, in total, from all of the different molluscs specifically, we are looking at well over 40 described species already. And I think we're probably near 50 now, which is very rich fauna, very diverse. I've shown some of the more classic examples here, some of the more iconic ones as well. So those include the ammonite like the Sigiloceros, which I just shown, but they also include other species of ammonites, such as this one. This one is also quite common. This one is called Proplanulaites petrosus. It's got a beautiful colour to it, very nicely preserved, still got some of the shell on it as well. That's a very nice example. Now these ammonites, they would be swimming in the sea, not on the seafloor itself. Somewhat similar to what nautilus and squid do nowadays.
Because it's very clear to say that the ammonite is not a nautilus, is it? That's a different thing.
No, they are indeed, they're not nautilus. However, they are somewhat closely related, and they did fairly similar things. The ammonites were a lot more diverse, and that, in terms of species and everything, but that also means that they were a lot more ecologically diverse. So they were doing slightly different things, but overall, if you picture, for the people behind the camera, if you picture what a nautilus is swimming around, catching little bits and bobs here and there, that would encompass a fair portion of what many of the ammonites were doing as well.
Right. Okay, yes.
Some of the other fossils that we've got here include the bivalves. Now the bivalves, there's a few different types here that I've taken out. They are by far the richest group. Bivalves alone, we are at well over 30 species already, nearing 40, which is absolutely crazy given that they're just, you know, a group. But at the same time, if you think about it, this actually does make sense. If you go to the beach nowadays and really start collecting a lot of seashells, you'll notice that there's quite a lot of bivalves as well. This is still true around the UK coast. The diversity is maybe not quite as high as it once was, but the bivalves are known as a very ecologically and species-rich group.
I mean, this looks like just like a mussel you'd find on the beach today anyway.
Exactly, and so that one is, the Latin name is Modiolus bipartitus, and it's closely related to the Modiolus mondiolus of today, which we call the horse mussel. So you're absolutely right, it does look like a mussel.
It's amazing.
It's in the same family as them. And so it's interesting that we've got, you know, in some cases, shells that are very, very similar to modern counterparts already in these rocks, such as this Modiolus counterpart. However, a shell like this one, for example, this is called Trigonia. Now, these bivalves were prolific during the Mesozoic and very iconic, but at the end Cretaceous extinction, they trailed off quite a bit. So there are still a few trigonid species alive today, but only in remote tropical areas, and they're excruciatingly rare. But back in the day, these trigonids were a bit more common than that, and a lot more diverse as well.
And these are filter feeders, aren't they? Or we think.
So most bivalves were indeed filter feeders, yes. But how they filter fed varies as well. So one of the very interesting things about bivalves is that they are highly adapted to their environment. So some bivalves are what we call epifaunal, which means that they live on the seafloor. Others are called infaunal, which means that they live either fully buried or halfway buried in the seafloor.
Right, okay.
And so by looking at the bivalves in a certain site, we can actually tell a great deal about the environmental conditions at the time. So that includes things such as the sediment of the seafloor, how high energy it was, how well oxygenated it was, how warm it was, and all these different kinds of environmental indicators.
So can we also tell if these were alive when they were buried and fossilized because they're closed rather than opened? Is that something, or is that not relevant as such?
It's hard to tell. I've not looked too much into the taphonomy specifically at this site yet. So far I'm focusing on species, but indeed oftentimes when we find bivalves with both valves still attached and close together, that can indicate an individual that died and got buried while it was still alive, actually. Yes.
Okay. This is beautiful, this one here. There's some colour on this.
It's very nice, yeah. So you see some of the shell left over. It's almost nacre-y on that one.
Look at that.
So that is a big bivalve called Phaladomya lyrata. Phaladomya is another type of bivalve of which there are actually pretty much no modern relatives. So that is also a very typical Mesozoic or Jurassic bivalve of which we don't have modern counterparts.
Right. Well, we're finding a whole snapshot of the ecosystem, aren't we? It's just amazing. Right, we've got something that's absolutely beautiful here.
Yeah, so this is a beautiful little gastropod called Purpurina. Now, this Purpurina is actually gone. The shell itself is gone. What we are seeing here is what we call the Steinkern. So the Steinkern is a German word which essentially translates to stone core, and it's a word that we use to describe when only the internal mold of the shell is left. And in fact, I'm not sure if it's picked up on the camera, but you can see that there's actually a gap in between where the Steinkern sits and where the rock is.
Yes.
That gap is where the shell would have been, but that shell has now been dissolved away, which leaves us with just the imprint and the Steinkern left.
Wow. That's amazing, actually.
Yeah.
And it's been flanked. What has it been flanked by either side there?
So there are indeed two little bivalves here. So this one here is the imprint of a scallop. The scallop was called Radulopecten. And over here we've got a Gryphea. Now we've got a much better example of Grypheas.
Let's have a look at
These are right here. And so these Grypheas are also commonly called devil's toenails. If you've gone, for example, to the Jurassic coast, there's one of the iconic fossils that you can find there as well. It's a slightly different species, but it is in the same genus as the one that we get at Lyme Regis. Now, these absolutely littered the Jurassic seafloor, and especially at Cerney Wick, they are by far the most common fossil.
Right.
Which is why many of the people even working in the Ice Age will find tons of Grypheas washed in next to their bones, just because they are so common that they have washed out of the original rock layer. what's interesting with this one, so you've got these two Gryphaeas, and right next to it, pretty much buried with it, you've got this nice long belemnite with it. So the belemnites, they are cephalopods as well, which means that just like the ammonites, they are in the group that includes modern octopus, squid and nautilus. But these were also prolific animals during the Mesozoic, and that also went extinct at the same time as ammonites at the end of the time of the dinosaurs. What's interesting about this fossil is that you can tell that clearly these animals were, lived together and pretty much died together as well. So it's a good indication of how, things that actually swam in the water column versus things that lived on the seafloor did interact with each other nonetheless in these ancient marine environments.
So are these death assemblages in many respects, and all these blocks full of all these shells and things, that is also helping us to understand the ecology of these particular molluscs in their lives, how they lived and whether they were solitary or not, or that sort of thing.
Yeah, it is absolutely delivering a lot of information on that, and in fact it kind of goes both ways. Typically, more common thing is because we have a fairly good idea of what these different types of animals were doing, what their ecology is like, which is something that we can do namely by looking at modern counterparts or by studying other sites and stuff like that. So we've got a fairly good idea already of what they're doing, which means that when we get assemblages like these together, we can use the information that we know about the individual species, pull that all together to really reconstruct fantastically intricate ecosystems and paleo environments.
That's really cool. That's really cool. Well, we've got two other little fossils we haven't talked about down here.
That's right.
What are we looking at here?
So
that's beautiful. That's like little scallop.
Yeah. So this one right here is gastropods. Now this one looks also to be the steinkern. I think there's a little bit of shell left on it, but it's mostly steinkern. It's not very well preserved, but I felt like it probably looked quite nice on camera.
That's lovely.
And you can tell that it's very much a different species to this gastropod over here. And so ecologically these probably would have been doing different things as well. I think, though I have no strong evidence to corroborate this was probably more of a grazer, whereas this one was probably more of either a scavenger or maybe even a predator.
Right, okay. And this is absolutely gorgeous.
This one's very nice as well. So this is called Oxytoma expansa. They are in their own family, but they are not too distantly related to scallops and mussels and oysters. But it is indeed a very nicely preserved specimen, this one right here.
Is it possible with certain preservation to be able to pick up coloration or anything like that? Is that something that we're able to do these days, whether they've got a pattern or a coloration or anything?
So typically, and this is very much the case with the specimens from Cerney Wick as well, and often the case in the Jurassic, the way that the specimens are preserved, they've been so strongly remineralized that there is very little left in terms of indications of their coloration. It is personally not my field of expertise, because that goes more into the field of taphonomy, and I'm more of a palaeo-ecologist. But it is definitely something that is worth looking into. Though my guess is most of these have been so strongly recrystallized, or in the case of this one, for example, where there's simply no shell left,
It's gone. Yeah.
there's no way that you're going to get any color out of that. So I think all the specimens here, it's impossible to tell what color they were back then.
And how do you go about assessing whether something is a new species? I mean, that's what sort of process would you go about? If you got, say we've got something like, say this ammonite, and it's come to your desk, it's a new species, but you don't know that yet. How would you go about coming to that conclusion? I'll put you on the spot there, Max.
Yeah, well, the main answer is really delving into the literature.
Yeah.
Which for the Kellaways is actually difficult because there's very little literature. But that does also make it exciting, and that does also mean that there is so much more opportunity for those new species. Because the Kellaways Formation has been so understudied, especially in rich sites like this, you're much more likely to find new species, just because less people have looked at the material. And so the way that I go by trying to figure out whether something is a new species or not is I look at all of the species that have been described so far from other Kellaway sites, of which there really aren't many, and many of those lists are average at best in terms of the quality of the identifications and the quality of the descriptions, as well as looking at fossils from the Oxford clay, which is the layer just above, so just younger than the Kellaways Formation, and the cornbrash, which is just below. So if we find species that are maybe present in one of those two, then it can be posited that indeed that species lived on or had already appeared in the Kellaways Formation. If you're looking through all of that literature and you're looking through all the species lists and you find something and you just think, wow, I'm really not finding any match for this. This looks like none of these other examples, because both the Oxford clay and the cornbrash formation have been studied in more detail. So the literature there is more complete. So if you find something that is really, you cannot find any matches for it, while it does obviously call for more searching, especially searching from other sites across the world from similarly aged deposits, you may be onto something good there.
Wow. Well, I think that's a really exciting part of this dig, and this is the most amazing part, and this is why we're also doing so much work to record all the data and the context and absolutely everything that we can, and get all that contextual information about the Kellaways, all of it, because as Max very clearly says, we're getting a lot of new species, new science, everything coming from this understudied area of the Jurassic rock. But it's just fantastic, isn't it?
It is.
These are beautiful. You can imagine them alive though. They're so perfect.
Some of them are so well preserved that indeed, and this one right here is still in the matrix, but when that one gets prepped, I'm sure that will be a museum worthy piece. It'll be absolutely beautiful. I can tell the preservation is perfect on it. You can absolutely imagine very well what this ancient marine environment would have looked like just by looking at how well preserved these fossils are. And it is indeed brilliant, like you say, that we are given the opportunity here to carry out this research, because the Kellaways Formation, the reason why it's so understudied is because it's quite poorly exposed throughout most of England. And so quarry sites like this one at Cerney Wick, where the Kellaways is very well exposed, offers such a unique experience, such a unique opportunity to really do some cutting edge science. And I find it fantastic that I get to work on this material, as well as getting to train people that maybe even have never worked with invertebrates before on this material. And these volunteers have been absolutely brilliant. It is just 2 days ago I was training someone that had barely worked with invertebrates before, and just 5 minutes after I finished my training and told her, all right, here are some of the rocks that we're going to smash, she found 2 entirely new species of science within the space of 5 minutes, which was breathtaking. I could not believe it. Yeah.
That is absolutely amazing. Were you just slightly jealous?
Maybe a bit more than slightly.
Well, look, Max, I am so sorry you are leaving us. I mean, it must be absolutely heart-wrenching to leave such an exciting site.
It is. I do not want to go, but yeah, it is very unfortunate. And I'm confident, in fact, that the project will be in safe hands. I've got a successor already that's going to help lead on the project in my stead. And I will still be working on this project remotely as well. Doing
for many years, I think, by the sounds
quite
of
a few years, yeah. And it's great to be working with such an experienced, as well as such a, in some parts, unexperienced team, because it means that we're really pooling different types of ideas together to get an absolutely fantastic project out of this.
Well, it's just beautiful, and thank you for bringing some of these to show us, because they are, each and every one of them, just so beautiful, aren't they? They really are.
Yeah.
Absolutely lovely. Thank you for that. A snapshot of the Jurassic Kellaways and the life that's going on within that incredibly diverse and rich, what is it, ocean? Would it be ocean or sea?
Ocean, sea, marine environment.
Marine environment, there we are. Thank you very much, Max, for telling us about these. Keep watching these videos. This is really, really exciting stuff. It's absolutely amazing. As I said, we've got potential new species. Well, I'm just going to say potential. I don't really need to say potential. We have pretty much guaranteed we've got.
I'm sure that there's.
Yeah. We got new species.
When the project comes out, there will be some pretty big announcements.
Fantastic.
That will revolutionise the mollusc world.
Well, wow. How about that? We're revolutionising the mollusk world of the Jurassic period. Absolutely fantastic. In fact, it's going to have knock-ons beyond, isn't it, really? The
Probably,
Jurassic.
yeah.
So keep watching these videos because it's all going on here at the Hills Quarry Products dig site in Cerney Wick, and we are constantly uploading these videos. They're rather raw, they're filmed live in the field, and the hashtag is Tusk Force.